Hello everyone, my name is Dilipar, first year MBA from SVC College. My topic is linear programming problem. Linear programming problem. It is the optimization technique for finding an optimal maximum minimum solution of a problem. It consists of four components: decision variables, objective functions, constraints, non-negativity. These four components creates formulation of linear programming problem. Decision variables. There are unknown to be determined subject to the constraints. It denotes represents x1, x2, x3, x1. It consists of variables dependent and independent variables. Objective function. A function which is expressed in terms of decision variables. The objective is to maximize the profit, minimize the cost. Zmax is equal to x1x plus 1 into 1 plus 2 into 2 plus 3 into 3 C1 C2 Cn cost profit x1 x2 xn decision variables. If the word given profit or loss, selling price, cost price and revenue constraints, it always represents on the use of resources like constraints, money constraints, time constraints, labor constraints, etc. It gives equality, non-negativity. It gives decision variables the value x1, x2, etc. because it gives profit. Procedure. Write down the decision variables and the problem x1, x2, xn. Formulate the objective function to be optimized dependent upon the decision variables. Formulate the other condition of the problem like resources, limitations, market constraints, linear inequality in terms of decision variables. The non-negativity constraints so that the value of decision variables do not have any valid physical interpretation. Let us discuss first question. A company engaged in producing a models namely X1, X2, performing three operations: painting, assembling and testing. The relevant data are given below. It's required for each unit sales price. Assumption: model X1 rupees 50, 1.0, 0.2, 0.0. Model X2 rupees 80, 1.5, 0 to 01. Total number of hours available for weekly assembly 600 hours, available 100 hours painting, 30 hours testing. The company wishes to determine the weekly product mix so that maximize revenue. Formulate decision variables. Let x1 be the first decision variable of model x1. x1 decision variable for model x1. x2 decision variable for model x2. Objective function zmax is equal to 50x1 plus 80x2. Constraints assembly time constraints 1.0 into 1 x1 plus 1.5 x2 600 hours. Painting time constraints 0.2 x1 plus 0.2 x2 100 hours. Testing time constraints 0.0 x1 plus 0.1 x2 30 hours. Non-negativity x1 x2 0. Let us discuss the second question. A company manufactures FM radios and calculation the radios contributes rupees 100 rupees and calculate rupees 150 as profit. Each radio requires 4 diodes, radio components and 4 resistors. For manufacturing calculators require 10 diodes and 2 resistors. A radio takes 12 meters and calculate takes 9.6 meters of time on the company. Electronics testing machine and the profit. Managers estimate 160 hours of testing time is available. The company has 8,000 diodes and 3,000 resistors in this stock formulate LPP. Decision variable. Let x1 be the number of radios and x2 be the number of calculators manufactured. x1 radio, x2 calculator. Objective function zmax is equal to 100x1 plus 150x2. Constraints. Diode constraints 4x1 plus 10x2 8000 hours. Restore constraints 4x1 plus 2x2, 3000 hours. Time constraints 12x1 plus 9.6x2, 9600 meters. 160 hours into 60 meters. Non-negativity x1, x2, 0. Thank you.